first problem of today, which is problem 14-18, जिसमें you have a collar which has a mass of 20 kg and it rests on a smooth rod. So once this word smooth arrives, then it means that you are not going to include force of friction in your analysis. This collar is being attached with two springs. One on the left hand side, let us term this spring as spring A, which has a constant of 50 Newton per meter, and then you have another spring which is attached with this collar on the right hand side, and this spring has a constant of 100 Newton per meter. So overall this collar is connected with two springs, and both have different values of K's. Each spring has an uncompressed length of 1 meter. It means that once this collar is in the position shown, that is at the center of this rod, both the springs are unstretched. That is, both of them have a length of 1 meter. Okay, now the statement says that if this collar is displaced 0.5 meters towards the right and then released from rest. आपने किया क्या है कि you move this collar towards the right until this S becomes 0.5. So this S is 0.5 meters, and from this position, let's say कि मैं कहता हूँ this is position number 1, you release this collar from position 1 at rest. Now, because of the spring force, both the springs will try to regain its unstretched position, due to which this collar is going to move towards the left. You need to determine the velocity of this collar at the instant it returns to the position which is S equal to 0. So once this collar returns to its center position, let's say that this is position number 2, then what should be the velocity of this collar at position number 2 as shown to you in the figure. So आपके पास एक collar है जिसके दोनों तरफ springs लगे हुए हैं. आप इस collar को थोड़ा सा displace करते हैं towards the right और rest से release करते हैं from position 1. You need to determine कि once this collar passes position 2, which is the position at the center of this rod, तो वो कितनी velocity के साथ जो है वो travel कर रहा होगा. Is this question clear to all of you? Statement clear है? जी. Okay, so चूंकि आपके पास यहाँ कुछ displacements involved हैं, which is say 0.5, कुछ forces involved होगी, मसलन weight होगा, normal force होगी, spring force होगी, और velocities involved हैं. So F, V और S, the principle which will give you a direct relationship between these two variables, between these three variables, is the principle of work and energy, which states that the initial kinetic energy plus work done by all the forces which are acting on this collar should be equal to the final kinetic energy, which is T2. Okay, one by one, let us evaluate each and every term, starting with the initial kinetic energy. What should be the kinetic energy of this collar at position 1?
The rest से start हो रहा है.
Since it is starting from rest, so it should have 0 velocity at position 1, which will give it 0 kinetic energy at position 1. Now, if we draw a free body diagram of this collar, the forces which would be acting on this collar are shown to you here. One is the weight of the collar, which would be acting downward. The second force would be the normal reaction force when you remove the rod connection from this collar. So you are going to get a normal reaction force here. Any other force which you want to include in the free body diagram?
Rest पे तो uncompressed है वो.
Between position 1 and 2, is there any other force which would be acting on this collar? What about the spring forces? Spring force F spring A as well as spring force F spring B would be acting in the directions as shown to you between position 1 and 2. Position 1 और 2 के दरमियान किसी भी एक पोजीशन पे मैं अगर फ्री बॉडी डायग्राम बनाता हूँ तो लेफ्ट स्प्रिंग चूंकि स्ट्रेच हुआ हुआ है वो इस कॉलर को टुवर्ड्स द लेफ्ट मूव करने की कोशिश करेगा. इसी तरह राइट स्प्रिंग कंप्रेस हुआ हुआ है, वो भी इस कॉलर को टुवर्ड्स द लेफ्ट मूव करने की कोशिश करेगा. Therefore, both the spring forces would be acting towards the left as shown to you in the free body diagram. Is it clear to all of you?
Yes, sir.
Okay, so we have talked about T1, which is the initial kinetic energy at position 1. It should be equal to 0. The kinetic energy at position 2 can be represented as half m V2 square, where m is 20 kg and V2 is an unknown quantity which needs to be determined in this problem. So kinetic energy is half mv square. Okay, what should be the forces that will be contributing towards work done? क्या weight work की तरफ contribute करेगा?
No, sir.
So weight would not be contributing towards work. Similarly, what about normal reaction, will it be contributing towards work done?
No, sir.
Since normal reaction is also acting perpendicular to the direction of displacement, so it would not be contributing towards the work done. So you can write UNC to be equal to 0 as well. It means that the only forces that would be contributing towards work are the spring forces due to spring A and spring B. Okay, starting with the spring force A. What is going to be the work done due to this spring force A, USPA? It is going to be minus half KA SA2 square minus half KA SA1 square, isn't it? यही होगा स्प्रिंग फोर्स की वजह से वर्क. Okay, can you identify SA1 and SA2?
Sir,
At
1.5 और एक 1 है.
At position 1, which is this position shown to you here, स्प्रिंग A जो कि लेफ्ट साइड पे है वो अपनी अनस्ट्रेच पोजीशन से कितना डिस्प्लेस हुआ है?
0.5.
0.5. और एट पोजीशन 2 स्प्रिंग A अपनी अनस्ट्रेच पोजीशन से कितना डिस्प्लेस हुआ है?
0.
0. So it means that SA1 is going to be 0.5 and SA2 is going to be 0. What about SB1 and SB2? स्प्रिंग B जो है वो पोजीशन 1 पे कितना डिस्प्लेस हुआ है?
Minus 0.5.
माइनस 0.5 कह लें, या क्योंकि वो आपका स्क्वायर आ रहा है तो माइनस साइन अगर आप इग्नोर करना चाहें तो आप इग्नोर कर सकते हैं और वो सिंपली 0.5 होगा. व्हाट अबाउट SB2? इट शुड बी इक्वल टू 0. पोजीशन 2 पे तो दोनों स्प्रिंग्स अनस्ट्रेच हैं, तो पोजीशन 2 पे दोनों स्प्रिंग्स का जो SA है वो 0 आ जाएगा. पोजीशन 1 पे दोनों अपनी अनस्ट्रेच पोजीशन से 0.5 डिस्प्लेस हुए हैं, यानी स्प्रिंग A इलोंगेट हुआ हुआ है और स्प्रिंग B जो है वो कंप्रेस हुआ हुआ है, लेकिन मैग्नीट्यूड उसका चूंकि 0.5 है तो इसलिए दोनों वर्क डन जो है वो हमारे पास जो है वो 0.5 आएंगे. सो ओवरऑल द इनिशियल काइनेटिक एनर्जी एट पोजीशन 1, जिस तरह भी हमने बात की, इट इज गोइंग टू बी इक्वल टू 0. दिस इज द फाइनल काइनेटिक एनर्जी. दिस इज द वर्क डन ड्यू टू स्प्रिंग A विच इज ऑन द लेफ्ट हैंड साइड. दिस इज द वर्क डन ड्यू टू स्प्रिंग B विच इज ऑन द राइट हैंड साइड. दोनों जो है वो पोजीशन 2 पे आके 0 0 हैं, दोनों पोजीशन 1 पे 0.5 हैं. सो वंस यू सॉल्व इट, द ओनली अननोन थिंग हियर इज V2. So once you solve it, V2 comes out to be 1.37 meters per second. So this is going to be the velocity of this collar once it passes its center position. Is this thing clear to all of you?
Yes, sir.
Okay. Can you identify the maximum stretch or compression in these two springs? Can you identify it?
Yes, sir. वो फाइनल पोजीशन पे हो, इसकी वेलोसिटी 0 हो जाएगी.
Okay, so we will put the final V2 to be equal to 0. That will give us the maximum deformation of these springs from its unstretched position. In that case, we are going to take probably S2 जो है वो कितना हो जाएगा? अगर मैं कहूँ कि मैं इसी पोजीशन से छोड़ता हूँ, ये मेरी पोजीशन 1 है, इस पे दोनों S1 जो है वो 0.1 हो जाएंगे, से ये मेरी पोजीशन 2 आती है जिसपे वो मैक्सिमम कंप्रेस हुए हुए हैं. उससे आप जो है वो उसको से S कर लें तो आपको जो है वो S की वैल्यू यहाँ से मिल सकती है. हो जाएगा, कोई इश्यू तो नहीं है.